Hello, hello. Today I will um, go over an example, a real data example uh, that involves regression and real practical problems one can face during dealing with the scenarios where we have more predictors than observations, where we have um, predictors that are categorical, where we have missing values. So these are the issues we will go over today. This file that you're seeing is something I will share on Blackboard. Uh, it's called as a data dictionary. Okay, this is a project I am working on in collaboration with Dr. Karen Flores at the School of Public Health, CUNY School of Public Health, and this is an abstract of an NIH grant we submitted a few years ago, and it got accepted, and we gathered the data, and I'm just showing you the data as an example how to approach modeling and inference and the potential problems um, that one can see even when you just try to do something simple as regression. Okay, but just so that you have context, I am I'm sharing with you the title: Social Networks, Acculturation, and Food Behaviors and Values Among Mexican American Families. And by the way, this data, anything related to this data and this project is essentially, if you use it, if you watch it, you are agreeing not to share it with anybody else. This is only for educational purposes within the class, and um, this project or the data or anything about it uh, should remain confidential, and you cannot share it with anything outside anywhere outside the scope of this class. Okay, but so that you know what this is about, you can just click pause and read the text. I just won't repeat, I won't say much, and during the analysis, will talk more about it, but so that you know, you have a reference for what this is about. This is obviously, this project is much bigger than what I will show you in class, but here you can see an example of in broad uh, strokes what is this about. So this is the um, data file, which will be available on Blackboard. And again, by using this, you agree not to share it anywhere. So let's look at the data first, okay? And we read D. Here. Oh, okay, so it's a working directory problem. So we set the working directory to source file, and then here we are back. Okay. Now, E, just look at it. So the first column is ID, and then we have HB1AC, hemoglobin A1C. it's a measure for the average level of blood sugar over the past 2-3 months. And since the subject is diabetes, it's something that they measured for every individual. Okay, and I mean, you can read more about it. But as far as we are concerned, this is a measure of the amount of sugar in the blood during the past whatever interval, 2 months. And we like to predict this, or we like to understand the relationship between this measure and many other variables. Gender, church activities, what are these? Well, we learn about them here in the data dictionary. Church. How long have you attended services or activities at this church? So this was a survey, and every individual was asked a certain number of questions, and they also measured the HB1AC, and they asked them about their family, about the relationship, about the people that they interact with, and about the habits of those people that they interact with. Okay, well, anyway, there are many variables here, and it's 52 pages, so I encourage you to go over this. This is what real data analysis involves. You start from this place, and there it is. Data is always not, most of the times, not clean. But anyway, let's look at more. Religion, how important religion is in your life, year born, age, and there's some redundancies. For example, year born and how old are you. These two are what we would call is this vector and this vector. These are going to be pointing in the same direction. What does that mean? Let's look at this. We have D, and then we have H, right? Let's call this X. And then we have Y, which is D, year born, right? So we have X and Y. And if X and Y are pointing in the same direction, what does that mean? That means that the angle between them is 0, right? So what is the cosine of the angle between X and Y? Remember, it's TX, so it's X transpose Y divided by the square root of what is that cosine? XY. It's almost 1. It should be 1 actually, because year born and age are should be the same. So maybe there's, let's see, actually this is very interesting. Essentially X, right? Age. So 2020 minus age. So if you're 20 years old, that means that you were born in 2000. So X minus this should be the same as Why? Ah, okay. So if you're, there's a one. There's a one that needs to be added. Um, so let's say if you're born in 2020, then your age should be. So if you're born in 1999, then your age shouldn't be 20. It should be 21. Anyway, there's a one shift. That's the whole thing. But the whole point is that here we have two. There's redundancy. What the age is telling us is the same as what the year born is telling us. Okay. Moving. How old were you when you first came to the US? Years, residency in the United States. How old were you first came to the US? So these two, this is what the real diction. You would ask yourself, well, why aren't they saying the same thing? Well, then we go down, okay, and then there's more detail here. And the details are very useful because then you can look at it and they say, okay, HB1AC, the range is from 3.7. There's a summary statistics to 9.8. The mean is this, standard deviation is this, and how many missing values? 10 out of 81. So we have 81 observations and 10 are missing. So we are left with 71, which is not a lot. For gender, there is nothing missing, so we have 25 male, 56 female. Church, nothing missing, but we see the categories here. And the values for church are 1, 2, 7. So this is a categorical variable where each of these numbers means something. Less than a year, at least a year, but less than 5 years. 5 to 10, 10 to 15. So this actually may make us think that this numerical value is a reasonable way to code so that we can treat it as a ordinal variable, that there is this order here from from a small amount of time attending the church to a long. But then the problem is the last two categories. I do not attend services at this church. I do not attend services at any church. This is 6 and 7. So we have to treat this as 6 distinct categories. That's it. There are no missing values. Church activity. And here's another thing. There is some imbalance. You see we have some 4s here and then we have some 23s. So I'm just a little bit skeptical how useful this variable will be, but we don't know. So let's just hold off making presumptions. Church activities has 6 missing values. And here it's also ordinal, from never to once a day. So here maybe, but I don't know what this dot is, so that's a different thing. Oh, dot is missing. 6 are missing. Okay, so now the question is that if these 6 that are missing coincide with the 10 that are missing here, then maybe we can use this variable because then those are missing that we don't care. Those data points have missing church activities that we don't care because those are the same data points that are missing the HB1AC. So let's just, I slowly go over this. This is 52 pages, but the process involves really going over all these variables one by one. You can't just automatic, at least in this kind of work. In this kind of work, you need to go over every variable. If it's text mining, then it's different. And we will see an example which will be the total opposite of this example. Okay, moving age and age are different. You know, sometimes people turn numerical values into categorical ones. And here it's how old were you, and then there's this age, whatever it is, right? Uh, and there's um, okay, so if essentially this is just saying that were you born here or not? Because if you're born, then let's see. I'm curious actually now. Moving. Okay, so this is just saying whether you were born in the US or not, and if you're born, then it's two. So most of them are not born in the US, except for one. And if you have such an imbalance, then this variable is probably useless because almost all the data points have this constant. There's nothing that distinguishes these data points according to moving. Let's see. Let's see. Years residence. You see, there's some variability, so we may hope that maybe there is some association between these numbers and the these missing ones. Everything except for the missing ones. Now, what had missing? It was church. No. Okay. So yes, we see this missing one here does not coincide with these missing ones. So then maybe an easy solution is just to ignore this variable. But we will get to that later. And then how many of your parents were born outside the US? And the range is 3 to 3 and unique values 1. So all of them have the same number 3. I would, if I wanted to use this, I would ask the researcher why 3, because how many of your parents should be 1 or 2, I guess, or maybe 3 has a specific meaning, but here it doesn't. 3, it says 3 means 2 parents. That's it. Now the thing is that all of them have the same value, so this is again going to be useless. Marine acculturation short scale, I don't exactly remember what it is, but it's about acculturation, and part of this research is about studying the association between the levels of sugar in blood and acculturation in the US for Mexican Americans who have recently moved from Mexico to the US, or their parents have moved, and how is that been influencing the levels of sugar in blood. Okay, then we have education, and again, the reason we need to go over this data dictionary one by one is to, at the very least, know which variable is categorical and which one it is. It's not, because they're all coded as numerical values. So education has 1 to 7. There is an ordinal. There is an order between the categories. As the identity of the category increases, the education increases. So this is one scenario where if we don't treat education as categorical, it may not be a bad idea, because the way it's coded is associated with the level of education. But we saw that this is not the case in um, all the variables. So let's just go back and let's look at education. Now, if we wanted to treat them, this is all numerical, but if we wanted to treat them as categorical, then we would refer to them as this. Now we have 7 levels. Okay. Now education 10, it's a summary of education in a way. So we imagine we collapse these two categories. 6th grade or less with 7th to 11th grade, and then we have 25 and 22, so we have 47. And then we have high school graduate or GED, which remains 19. Some college, but no degree 2. And then anything else, any college, all of it just adds up to 13. And I would have a conversation if there's a reason why one of them is preferable, but from a modeling point of view, something that bothers me is that the imbalance we have here. We only have 2 in this category, and then we have 47 here, and then we have 13. It would be, as a rule of thumb, it's preferable to have more balance, because if imagine in the extreme case where all of them have any college, right? Imagine all of them any college. Then there is no variability. It's a constant variable. It's a constant predictor. There is no information in it. Then we have marital status. Again, it's numeric, but here we don't have any order. There is no order. There is no natural ordering. We could easily switch the order between these categories and use different numerical values. So the marital status, if you don't code it as categorical, it will be treated as numerical, and that will lead to problems. Again, I'm repeating myself, but this is important. You need to go through all the variables one by one and identify those that need to be treated as categorical and those that need to be treated as quantitative, numerical. Just say that in general your halt is, now here we have an order, so it could be reasonable to use them as ordinal. Here is a collapsed version, and just I mean, not, this is not coming from anywhere deep, but here looking at this, we have 5 categories. To begin with, we are asking the individual themselves, and it's pretty arbitrary. What is fair, good, very good? What's the difference between good and very good and excellent? It's very subjective. For some person, something might be excellent, which for somebody else could be poor, right? So there is some subjective, but maybe that actually the way people see themselves is also associated with their levels of sugar. Now here, this is, I think, a little bit easier and more reasonable. It's because it's binary, poor or good, more or less. So it's either good or bad, and it becomes a little bit less arbitrary, and it is obviously categorical. But since we have only 2 categories, whenever we have only two categories, it does not make a difference whether we treat it as categorical or numerical. Let's look at that. So um, oh, these will have to be lowercase. Okay, this is not what I was looking for, but okay. Next, I want to show you why it and how it doesn't make a difference if we use it as a factor, okay, and or as a, in other words, as a categorical or numerical when it's binary. And here, let's look at this. First of all, let's just start from the beginning. In this line, I'm removing all the data points, samples with no data in the response variable. Then I am running a simple linear regression. Factor and summary fit. We're gonna have it here too. Okay, I mean there's this general health. Well, the mean is this, and then general health negative 0.6, and I mean if general health only explains 6% of the variability, but nevertheless the responses are significant, and it's negative. So now what does negative mean here? Means this. You have two numeric values, so those who have good, very good, or excellent general health, or think they have, those who think they have good, very good, or excellent health, on average, their levels of blood sugar is this much less. Okay. Now we do a linear regression where we treat this as categorical. Sorry. And we numerically we happen to get the same thing, but here's the thing: we should be careful how we interpret this. And when we take this as category, when we treat this as a category, okay, then we have two categories, 1 and 2, and whatever order it has, the first one becomes the baseline. Okay, so and everything will be compared to a baseline. And then you have a coefficient for the first category, which will be 2. If we had 3, there will be another category, another coefficient for 3. But when we have, when 1 is the baseline, that means that the coefficient we get here for 2 is 2 compared to the baseline. So again, 2, good, very good, or excellent, and average have this this much less. Now let's do the same thing. We had the general health, right? Okay. Let's see if we, just to see. I want to show you that now the scenario is very different. So general health, what was general health? Poor, fair, good, very good, excellent. So numerical values, again, there's an order, but yeah, it's an order. And so it's reasonable to treat general health as numerical, and we want to see if we see an association. And yes, we see. And it's the coefficient is significant, and it's negative 3.7. How do we interpret this? Negative 3.7 means that those who have, for example, fair, on average, their blood sugar is 3.7 less than poor, or excellent is negative 3.7 less than very good, or very good is negative 0.37 than good. Okay, and this is what we get. So the general trend is that if those who have a view themselves as being healthier tend to have lower levels of blood sugar. That's all we see. Now let's treat it as categorical, and we see the numbers totally change. Now we have 4 coefficients, 2, 3, and 5. And remember that general health had 5 categories, so everything is now in comparison to poor. Now everything is in comparison to poor. And as we can see, 2, those who have general health category 2 tend to have blood sugar of negative 1.4 less than, I mean, it's not significant, but let's just say negative 1.42 less than and poor. Okay, so now fair is compared to poor. That's category 2. Negative 1.78 is now in comparison again, not to 2, it's to the baseline 1. So those who, just try to back that up. Those, okay, sorry. Those who who view themselves as having good, category 3, good health, tend to have, on average, blood sugar levels negative 1.78 less than those who view themselves as poor. And those who view themselves as having very good health tend to have on average negative 2.36 sugar levels less than poor. Now the interesting thing is that we see that the pattern here, these numbers are increasing, so the better they see themselves, then the more the difference. That trend changes here, and to begin with, this is not significant, so I don't know how to interpret it, but what we can see is take-home message is that it's significantly, when you have more than 2 categories, then and there is not a natural order in the categorical variables, then obviously you need to treat them as categorical. But even if there is, the results may not always 100%, obviously they don't agree, but there's a decision to be made, and there is no one formula that leads to this decision. And we will get to that, like how do we treat this, but for now we're just observing and seeing looking at the data different ways and seeing, getting to know the challenges. Okay. Now another thing is that somebody might ask, okay, what's the on average what's the difference between somebody who is excellent and very good? Well, it turns out that those who view themselves as having excellent health have you have to subtract these two numbers. So let's say this is 2.4 and let's say this is negative 1.7. So the difference is 4 and 3, 7.7, right? So those who view themselves as having excellent health tend to have blood sugar of 0.7 more than those who see themselves as very good. Okay, and that might be counterintuitive, but remember, this is self-reported. So maybe those who see themselves as having excellent health, maybe they're just too optimistic, or maybe their standards is just, I don't know, maybe if, because when you say excellent, then there is no doubt, and when there is no doubt, then that statement becomes questionable, because how can you be so sure that it's all excellent? And maybe you're in denial. I don't know. I'm just saying that these are all the things that are domain specific, and actually these are not my expertise, but these are all things that come into play, and you will have the conversation with that domain specific expert. I am having that with Dr. Flores. So um, that needs to be um, happening. Anyway, okay, let's move on. Categorical, which lend themselves to numerical. And then here we have variables that we can't really use because there are 63 missing, 78 missing, 52 missing, 47 missing. Healthcare, okay. There is nothing missing, but we have 5 categories, and there's nothing ordinal about that. Categorical, 3 categories. Anyway, you have to go through all of them, and I gone through it, so you can do that on your own, but you get the idea.